Hello, everyone. Welcome to the session 2.1, BIM-enabled design tools, information management, and collaborative environments. The first paper will be presented by Al-Akbar Kamari, and his paper will be Value Diversity as a Driver for Renovation Design Support, a clustering-based approach to accelerate the exploration of design space. Please, Mr. Kamari.
Thank you very much, Edmund, for a very nice introduction. Good morning, good afternoon, and good evening, everybody. As you can easily realize from the topic, the core focus of this project is on renovation of existing buildings. So the main question may arise is why renovation? So if we can go to the next slide, please. Yeah. So let's look at this building. Can you imagine how many of such a building exist in the world? So a significant part of existing building stock in Europe is older than 50 years old. These buildings will still be in use by a period to 2050, and they use a lot of energy. So there is a lot of value for renovation of such a building. However, from other sides, there is a high level of complexity from the availability of different renovation interventions, building conditions, and architectural transformations that we need to be able to deal with. So our solutions to facilitate this task and problem has been development of the tool which we have been working on within the last 2 years for rapid generation and evaluation of building renovation scenarios. I said scenarios. Here we define scenarios as a specific selection of different renovation alternatives, different renovation approaches, renovation features, and renovation attributes. So yes, as you can see here in this slide, for instance, an example can be for renovation of a roof. We can select insulation from outside as a renovation approach, and that renovation may have several type of features or attributes. And a scenario will be a specific selection of different alternatives, approaches, features, and attributes. And obviously, the next step is evaluating these scenarios against some key performance indicators such as indoor air quality, embodied energy, daylight analysis, indoor thermal comfort, so on and so forth. However, evaluation of some of these KPIs are computationally expensive. In this paper, we are particularly interested in working with such high fidelity simulation because they can generate very useful precise information about renovation option, but due to their relatively long run times, they significantly limit the number of scenarios that we can generate and evaluate. So to solutions to this problem, our contribution in this paper is we developed two complementary strategies for sampling the full renovation design, including uniform, random, and n-array aspect coverage. And secondly, we study and integrate two clustering techniques in a new version of the tool, which we name PARDIS. PARDIS for Process Integrating Renovation Decision Support, to clustering the KPI simulation outcomes for given scenarios. And we applied that framework to a case study. So here you can see we are integrating, actually as the workflow, we are integrating sampling and clustering methods to our already developed scenario generation and evaluation engine. So for sampling methods, considering a complete renovation design space specified by a given action tree for generation of renovation scenarios, our workflow samples a subset of this space used to approximate the full design space using these two different uniform random sampling and n-array coverage sampling. And for the clustering methods, we identify clusters of scenarios to identify groups of scenarios that are similar in the outcome. So simply to say, clustering is used to categorize similar scenarios with similar outcomes. So in this paper, we applied the framework to a single detached building, residential detached building here in Denmark. So we generate 1 array, 2 array, and 3 array aspect coverage sample sets and 5 uniform random samples within 1,000 scenarios per sample set. As you can see in this slide, the table for runtime and the number of scenarios, and at the right you can see how after the scenarios has been generated and piped into the simulation, they have been visualized in a scatter plot within 2 different type of clustering methods we have used. As the comparison between the 2 sampling methods we have used, the results show that both strategies are highly complementary. Aspect coverage tends to produce relatively high-performing scenarios that approach the Pareto theorem with a relatively small number of scenarios sampled. Uniform random scenarios from other side, instead, it covers the whole KPI space with a higher density in the central region and decreasing density away from the center. So, and then for comparison between the clustering methods, including k-means and dbScan, the results shows that dbScan produces significantly more intelligible clusters in the 3 coverage sample sets compared to k-means. However, from other side, in the uniform random case, k-means separates the scenarios into equivalently sized vertical bands. Which while somehow arbitrary, is more useful than dbScan, placing all scenarios into the same cluster. So as the conclusion of this project, our result suggests that the 4 sampling strategies should be used in a complementary way and can be gracefully scaled up to generate larger sample size with a correspondingly steady increase in design space decision-making information revealed in the clusters according to the amount of time that the user is prepared to take on scenario KPI evaluation. And in this paper, particularly, we were working with the 2 KPIs. So moving up to more KPIs raises the issue of how to visualize the clusters that have been discovered. For instance, move to use of 8-dimensional KPIs space. For this, we are currently using principal component analysis as a means to incrementally reduce the dimension from 8-dimensional to 2D and 3D. So that was my presentation. Thank you very much for your attention. And please have a look at the paper. We have provided a lot of detail there. Thank you.
Professor Kamari, I would like to call the second presenter, Paul Poignet, collaborative workflow and version control through open source and distributed common data environment. Professor Poignet.
Hello everyone, thank you for the introduction. So yeah, today I will talk about our paper that we wrote with Dimitri Ștefănescu and Eleni Papadonicolachi. So can you please go already to the next slide? So here is a slide about the contents. So first, introduction and problem statements. Then I will present some existing alternative to the centralized BIM approach. Then I will present Speckle, which is an open source common data environment for IC. Then present what there is towards a okay, sorry. So today, basically what we are facing, people are exchanging a big amount of data, like big Revit files, and then if one is doing one change, one has to save the change and resend this file again. So this creates large data payloads, and tracking changes is very problematic. It's inefficient for design communication. So what we are trying to do is, instead of resending same file, is to just send the data that has been changed, right? So that would minimize data payloads. Tracking specific changes would be easier, and this would also enable better communication. It will also create a clear authorship and history throughout the whole design process. So yeah, in this slide, ideally, we would like to track data exchange between different stakeholders that are involved in the same design process. And here we are calling this flow of data a stream. And when you pass from one version to the other, you go from S0 to S1. So there are existing alternatives to the centralized BIM approach. For example, the building data community group is trying to align with the existing technological standard from the semantic web through common data environments, CDEs, or Drumbeat, which was also an implementation. It was a REST API also developed by the linked data community. And in practice, there are engineering and consultancy firms that develop their own tools, such as Bureau Rapport with the buildings and habitat object models, which is a collaborative computational development that links different software platforms. Or here you have Proving Ground, which is a small side and leading digital design consultancy practice that delivers custom interoperability workflows for AEC clients. So they're doing a lot of research and development, and they are also trying to map the different flow of information in the design process. So those are the main key points that we can retain. We have to improve interoperability through custom developments. We have to keep geometrical objects as lightweight as possible. We have to use extensible neutral formats, and we have to keep things open source. And keeping things open source is important so that we can combine all the different efforts from the different companies. So here now I introduce Speckle, which is an open source CDE, which connects multiple machines and software environments. It also lives in the clouds, and the data is controlled by the user who can actually give specific read and write permissions to other users that shares the same data. Here's a slide just describing, comparing the REST API from Speckle with the semantic web ontology comparison. So you have both URI and URL. You have also a specific syntax, XML or JSON LD for the semantic web, or just JSON for Speckle. I will skip that. Then what we are interested in is to look at version control system in software engineering. For example, GitHub is one of the most popular version control platforms for programmers. You have branching, which is a fundamental means of launching a separate development branch. And there are different 3D repo actually kind of took this version control system, but for 3D environments. So it moved from the diffing in GitHub for text-based file to 3D diff technology that allows you to compare changes between different 3D object files. Constru it was also developed by Thornton Tomasetti, engineering firm based in USA. It enables interoperability amongst multiple software platforms and offers different workflows and version control capabilities such as one-way, round-trip, and modal merging. In Speckle, you have something called the stream revision history that allows you to actually keep track in the same stream or collection of objects. All the objects that have been added, removed, or are the same depending on when you compare two different versions in the history. So it allows you to see the similarities and differences. And here it kind of works a bit like the 3D diff in 3D repo that I explained previously. This is called the stream diff, which is a diffing mechanism comparable to git diff in GitHub, where you can compare the differences between two different streams or revisions. You also have a project timeline history that allows you to track the connection between the different streams that have been created, sent and received between different software environments. So there is a graph that is implemented in the platform where you can actually see live all these connections. So if you send 3D data from Rhino and you receive in Revit, you will actually see these links. And we actually try out Speckle in a workshop with 11 undergraduate students in architecture. This was a 2-week workshops in 2018, and this was for the design and fabrication of a freeform strip-based structure. And basically, the idea was that we wanted to exchange design ideas, wanted to keep track of the stream's design history and keep track of the project's timeline history. So using the Speckle environments actually enable us to do all this amongst the students. So you can see we start with the definition of overall abstract network. Then there is a base topological mesh for the design that is generated. Then the mesh is relaxed. Then the segments are generated and they are all unrolled and nested for fabrication. So this used the project timeline history in Speckle for the workshop. Here's last slide for discussion and conclusion. So I think there is a discrepancy between academy and practice. There is a slow release of open standards versus fast-paced software development in industry. We have to take into consideration the latest technological developments from the software industry. And there are other points that you can hopefully read in the paper, and I will stop here. Thank you.
Thank you very much, Dr. Prunier. We really appreciate it. Merci beaucoup pour votre présentation. The next presenter will be Carlos Arturo Osorio Sandoval. And the paper is Discrete Event Simulation and Building Information Modeling Based Animation of Constructions Activities. Dr. Sandoval.
Hello, thanks for the introduction. Just to clarify, I'm still not a doctor. I am completing my PhD. So if we can start with the first slide, please. Okay, so construction simulation is the method of modeling construction systems to understand their behavior and experimenting with the model. The prevalent construction simulation approach is discrete event simulation, which represents a system as its state changes at separate points in time at which events occur. A simulation model allows us to track outputs of interest, for example, time and cost, as the events that change the system happen. Additionally, we can obtain insights on resource utilization and use them to optimize an operation during the planning stage. This was supposed to be moving, but I don't know what's happening with the slide. Is a bit slow, I think. So simulation is widely used mainly by the academic community for several applications, including, for example, estimating the impact of diverse variables on the performance of construction operations and projects, for example, weather, labor absenteeism, equipment breakage, delays in procurement, supporting decision-making and resource management, and studying and improving construction operations. However, despite its potential, construction simulation has not been fully embraced by industry practitioners for multiple reasons, including, for example, the amount of data, skills, effort, and time needed to create a simulation model, and the abstract and confusing way in which the results are usually presented. For these reasons, researchers in the field of construction simulation are seeking for ways to facilitate model development and at the same time enhancing the results visualization. Two promising technologies that can help us to overcome these challenges are building information modeling on the one hand and game engines on the other. BIM can be used in combination with construction simulation in different ways. For example, quantity takeoffs generated using BIM can be used to calculate the duration of construction operations or to define how many entities a model requires to be completed. Another approach is to assign simulation models of construction activities to individual building components of a BIM model to define complex simulation models. This approach also enables the reuse of simulation models across different projects, which is generally not possible. We are proposing this framework for the integration of BIM and simulation modeling. It is composed of 5 main modules. The environment, which is preloaded with a library of generic simulation models of different construction activities. The user input module, that includes the facility to import existing BIM models. The preprocessing module, which automatically generates a BIM-based simulation model. The simulation module, in which users can experiment with the model, and the visualization module, which produces reports and simulation-based animations. The framework was implemented in the Unity game engine. Most of its components were developed as C# script game components, which are basically pieces of code that implement the functionality of the game objects in the scene. A key component of the framework is the constructable element class found in the environment module. This class is an interface between the BIM model and the simulation models of the construction activities that extracts data from the BIM elements and translates it into the requirements of the simulation models of construction activities. It can also enrich the extracted data to include required parameters that are not contained in the original BIM model, but that can be computed from its product parameters, for example, formwork areas for a concrete element. And other important components are the generic simulation models of construction activities, which basically consist of parametric simulation models that represent the construction process of a variety of products of the same type based on product parameters and project-specific constraints at the activity level. These models consist of a control unit that determines the flow of the system through a predefined parameter-based decision mechanism, and the tasks that specify which resources change, how they change, and the time span over which the changes occur every time that one task takes place. After preprocessing, each generic simulation model becomes specific to represent the construction of the BIM component that they are assigned to. All the activity simulation models in the scene are composed together to represent the construction of the whole project using a distributed simulation approach. The trace file component stores the information required to visualize the simulation results. During each run, a new time-stamped trace file is published every time that there is an update on the system. Basically, a chronologically ordered set of trace files is a detailed log of what happened in the simulation. And to produce the animation, the system uses the information contained in these trace files to place 3D models of the resources at their corresponding locations as the model progressed in time. At a coarser level of detail, BIM elements could be, for example, just hidden or shown, depending if they are completed or not. Compared to traditional 4D modeling, these type of animations really get into the detail of resource interactions and site level changes because the locations and status of the resources are known during the simulation. In turn, it depicts the construction processes more accurately. We can see an example on the screen right now. So we can actually see how the resources are changed location, position, orientation as the project progresses. And in conclusion, the proposed framework leverages BIM to reduce the skills, effort, and time required to develop complex simulation models. It provides an environment to experiment with different construction alternatives and resource constraints without the need to reformalize the simulation model. And what is more, the framework allows users to develop simulation-based animations using existing BIM models. These animations have many potential applications, including planning and decision-making support, and they also enhance how simulation results are presented, making them more user-friendly to domain experts that are unfamiliar with simulation. And thank you so much.
Thank you very much, Mr. Sandoval, for your presentation. We're going to the next one, which will be presented by Carolina Yosino, using BIM and GIS interoperability to create CIM models for USW collection analysis. Please.
So, hello, thank you, Edmond. Hello, everyone. And so, hello, everyone. My name is Carolina, and I will present my work about using BIMgis interoperability to create a model for urban solid waste collection analysis that I did together with my advisor, Sergio Leal. First, this is the summary of the topics that I will address today. First, I will introduce the topic, and I will explain about urban solid waste collection and SIM concept. Then I will explain how this research was done and the results. Okay, so well, there are okay. There are two main macro areas in civil engineer, constructive and urban engineer. There are have specific technologies, BIM and GIS. Research uses SIM to join these two macro areas to analyze urban solid waste management here in Brazil. So basically, solid waste collection in Brazil is a very expensive service that, if not well made, it impacts health systems. So our proposal is use this instance as a source to optimize collection quality and still reduce expenses. And we apply SIM because, based on Thompson definition, SIM returns several benefits, such as analysis based on different data sources and simulation of the natural movement of the city. And to use SIM properly, it is critical first enable the interoperability between GIS and BIM systems without data loss, and enable access to BIM to use urban data, and that's to store the code and manipulate these data. So now I will explain about the methodology of this research. Basically, the developed scene modeling was divided into three main parts: BIM modeling, GIS modeling, and their integration to create scene modeling. Now I will start with BIM process. So the BIM process can be divided in four main steps. The first one, define the BIM requirements. The second, choose the BIM software. And the third, build the model based on volume, parameters, and your reference properties. And last, export the model to GIS file system. So here is a sample of building model we developed. We use default fields such as area and volume. But we will also create new ones to set urban solid waste properties like production rate and building usage. Sorry. The second part of the modeling is about to develop of the urban environment with its volumetry and topography. It was based on GIS technology to obtain this information. So the GIS flowchart has three main steps. First, the definition of GIS requirements. Step 2, choose software. And step 3, urban environment and topography modeling. About the software choice, we opted to use two software, both from Esri company. For urban environment, we use CityEngine because it opens OpenStreetMap's data and creates non-parameterized urban volumetries. For data integration, we use ArcGIS Pro because it supports different files types and analyze simultaneous data in same project. And finally, the last stage of the modeling is the integration of all the data for the joint analysis for the construction of a sim model. This stage has 4 main steps. The first step is the insertion of previously BIM and GIS models. The second is the collection points creation. Third one is geometric data manipulation. And finally, route creation and optimization. Now let's cover all 4 steps in details. So the BIM and GIS models will be integrated into the ArcGIS platform in a 3D layer. The data is georeferenced on its own source platform, so the important will insert the structures in the correct location. Then, after that, it's time to define where the collectors are. So points are created on the map to define the collector's location. Their capacity are inserted as a parameter in each point. And after that, we run a Python script to transform a set of geometric data into a single point. This point will receive all the parametric information because it is not feasible to assign urban solid waste parameters to a set of geometric data. So now it's time to identify which buildings each collector should serve based on its location. Thus, another Python script ensures that region uses smallest numbers of collectors by using the most of its capacity. And lastly, the system analyzes the best routes for each collector, the shortest routes. Together, these analyses enable each collector to maximize its loads and optimize its routes. So the conclusions, these works use BIM based on GIS and BIM. You use SIM based on GIS and BIM to save public costs in Brazil through an optimized collection planning. Lastly, this model can be used for other areas such as energy, sewage, and public lighting. So is that? Thank you very much.
Last of this first part will be presented by Luki Pratama, and it is the BIM GIS implementation for rebuilding after a disaster, a critical evaluation. Please, Mr. Pratama.
Okay. Good morning or good afternoon, everyone. So right now I will present my paper about BIMgis implementation for rebuilding after disaster. This is more of a general review of BIM and GIS implementation in general. And this paper is a collaboration between me from the University of Washington and my colleague, Muhammad Sadra Lazani from the same department, under supervision of several faculty members from University of Washington. So I'd like to bring our attention to issue of integration and interoperability between BIM and GIS. So as has been explained by the previous speaker, BIM and GIS are two different tools for different disciplines. But trying to integrate both tools can create an interoperability because they are simply different formats in using the different industry. So there has been increased interest in studying the BIM-GIS integration, and that's why we have to understand how far has the knowledge base progressed around the BIMgis integration. In order to achieve that, we attempted to conduct a literature review on BIMgis integration. And those are done to achieve these goals, which we hope to be able to contribute to the knowledge base of BIMgis integration in general. So the first goal is to identify current trends in BIMgis research, to report on existing knowledge, to provide a critical evaluation on the BIMgis integration, and to present recommendations for future studies. Okay, so as I've mentioned before, we did a literature review. We conducted a digital search query on the ASC library, which yielded around 274 publications from 2007 to 2018. And we plotted each publication to their respective year. And we found that indeed there has been an increased interest in research around BIMgis integration, with the year of 2018 yielded the most results of publications in this area. So among these publications, we selected 33 publications to find general research themes. So generally, there are three main areas that we found interesting. First one is the BIMgis integration benefits in general, and the data exchange of BIMgis. And also, the third one is the BIMgis integration for disaster mitigation and emergency management. Okay, it looks like my slide is disappeared for some reason. All right. Well, let's just proceed. On to the first topic that we found. Of course, it's a pretty familiar topic, the BIM and GIS key strengths. So we identified the BIM and GIS separately. As we all know, BIM is a platform that allows AEC to pull data, not just 3D data, but also cost schedules, and also in some cases, energy management, which can be pulled at any time consistently. So, which is why it is called as a multi-dimensional tool. Okay, on to the next one, which is the GIS, which is a different tool because it's mostly used by urban planning. It is mostly a topography data management system that includes topographic data and human-made phenomena grounded in a geographic reference system. And its main advantages include spatial analysis that supports 3D measurements, facilitations of identifications of buildings, and enabling users to analyze and predict remaining service life of infrastructures. So on to the next theme that we identified is the data exchange between BIM and GIS platforms. There has been many attempts to bridge the BIM and GIS, and mostly they utilize IFC to bridge information between BIM and GIS. However, these created issues in bridging the data because there can be data misalignments when conducting the export between BIM to GIS, or the other way around, which can make bidirectional data conversion difficult, which is also experienced by different aspects of BIM conversion. So there has been solutions by creating like a bridging tool that bridge the conversion between BIM and GIS. One of the solutions is to create a universal building model, which convert the geometry and semantic data of BIM to translate into GIS. All right, so the final theme that we identified is the BIMgis utilization for emergency and disaster response. On a larger scale, for the disaster response, BIM and GIS can be utilized to make a better decision on building critical infrastructure after a disaster struck an area. On a smaller scale, there has been attempts to create a navigation system for emergency escape route on a building in an event of emergency. So among those three topics or themes, we identified several gaps. We found that a lot of research did not take full advantage of BIM and GIS. They mostly revolve around bridging the 3D models. And there might be some increased requirements from the users because they might not just need the 3D models. They might need the schedule or cost data. And also there's a little attention being given to spatiotemporal modeling, which is pretty common in other areas outside of AEC, but we have not yet seen a lot of studies about that in this area. So in conclusion, there has been indeed a lot of progress in this BIM integration, BIM GIS integration, but there's still key areas that might potentially be studied, and there might be a lot of other uses that might be interesting to study for future researches. So that is all for my presentation. Thank you for your attention, and feel free to ask for questions even outside of the presentation.
Thank you very much, Mr. Pratama, for your presentation. And I also like to thank all the presenters for respecting the time. Now we're at the question and answer period. And I would like to entertain some questions. I have to say that in the right side of my screen, I see no questions. So I would like to wait a little bit unless we can hear someone. Maybe it could be live questions. I don't know. Yes, Eduardo.
Yeah, there's questions. Click on the comments tab in your right side.
Yes, but I don't see any in here.
Comments?
There are comments. The comments, but they're...
Here's the first one.
Okay, all right. Now I should have... It's a question from Jacob Beats, and it's to paper 2.1. How did you gather the KPIs? How many cases have you looked at?
Yeah, I hope you can hear me. Thank you very much, Jakub, for a very nice question. Actually, I would like to, I can give you a history about this huge project we are working on. It's called Revalue. And then it's for the last 3-4 years, this project has been running. We have some PhD students working on that. I have been also working before as a PhD and postdoc on this project. So I have a background in architectural engineering. So I basically have been working actually with these KPIs. First, looking at sustainability, looking at building regulations here in Denmark. And secondly, after we put goals for developing such a tool, I have to also appreciate the great help from my dear colleague, Dr. Karl Schulz, who helped us from the computer science perspective for development of such a tool. So basically, we started to consider, okay, why are we developing this tool? Who is going to use it? Where in the process is going to be used? And little by little, we gather a lot of information in order to help us to select between the fit and right KPIs that can support particularly the decision, particularly during the early design stages, and in very close connection to regulations that today we have in Denmark. So I have to also underline that actually another part also has been due to the size of the project, we had this opportunity to go in a deep discussion with several practitioners, especially architects. And so all of this has helped us to also gather the KPIs in this project. I would like also to underline that there is a table including these KPIs, which is actually originally we have a larger list for these KPIs. But technically, we are also working on extending our simulation engine for simulation of them. So, but you can find a lot of information and references to my own previous publications with respect to the KPIs. But basically, one key reference can be sustainability-focused decision-making for building renovation, which I published in 2017, sorry. I hope it was the answer.
Thank you. There is a question for the presentation number 2, Paul Poignet. Appreciating the thoughts of understanding the needs for version control, the person wishes to understand how Speckles is different from GIT Hub.
Yes, hi Singraj, thank you for your question. I use this analogy just simply to explain that in GitHub, when you publish codes, you have a diffing comparison between different text files. So you see the text that have been added, the text that has been deleted, and the text that is in common. So basically, Speckle uses a similar technology, but for 3D objects. So you will see the one that have been deleted, the one that have been added, and the ones that remain the same. And you have other web-based platforms such as 3D Repo that also use similar technologies. So basically, it's just an analogy from text files to 3D objects.
Thank you. Actually, in my right, I see no more questions unless somebody would pop a live one. I'm not familiar with too much with the system, so I think the host probably should intervene and to let me know if we pause for the rest of the 10 remaining minutes, and then we continue was probably at noon. I mean, noon my time.
If there's no more questions, we can start to prepare for the next group of presenters. So we if there's no other questions from the audience, we can thank you all, and if you can leave the room, we can make space for the other 6 presenters. Thank you.
Thank you.
Thank you. So do we start immediately or we start at noon?
Just a second, so that the other presenters can enter the system. And
but do you start immediately
right there,
or at noon?
I'll tell you, not immediately. Just a second.
Sure, fine.
I think there's a question for Carlos. Bon, yes, I read. Gone. Let's see. Maria Angela is here. Okay. So we can go on with the next one, Edmond.
Right now?
Yes.
With
just a little bit.
Yes, I would like to know if the presenters are there, all of them.
Maria Angela is the next one. She's here.
Yeah, hello.
Okay. Will be just voice note.
Maria is the next one. She's here.
Okay. Will be just voice note.
Maria is the next one. She's here. Okay. Will be
Yeah, I think.
Okay, Maria, you'll not be able to use the if you're not using headphones. This can be a problem. Just a second, I'll put your slides and we can go on.
So yeah, hi. My name is Mariangela Lazani, and I'm going to talk about whole life cost integration with building information modeling. Yeah. Okay, so first I'm gonna introduce the 7D BIM project, talk about the project partners, the context, the scope of the project, aim and objectives, and then the outputs of the project, the process model, the prototype application, and then some other outputs in the press. So yeah, the project has been branded as 7D BIM, and you can find a lot more information on the company website, cardipcard.com. Yeah, I'll proceed to next. So yeah, the project was a partnership between the Cartwright Pickard and the Macintosh School of Architecture, the Glasgow School of Art, funded by Innovate UK through a knowledge transfer partnership program. It was also supported by 8 industrial sponsors, also project partners, engineering firms, developers, and an insurance company. So yeah, a bit of motivation for our project. So the UK government targets for the construction industry outline the reduction of whole life cost, capital cost, greenhouse gases. So very ambitious targets, and we're just making a bit of a contribution towards those achievements. So the same reports outline the need for the productivity, for improvement of productivity in the construction industry by following principles that are already used in manufacturing. As you can see, there's a huge opportunity to improve productivity, and BIM can assist in doing so. So the research has shown in the literature that the cost of operating a building is 4 times the cost of actually building it. So there is a need towards looking into the whole of life, not just capital expenditure. So what is 7D? We all know the 3D capabilities in the industry that are widely used, but unfortunately, the industry doesn't use the real potential of BIM, which is in the data and information attached to the model. So the aim of the project was to integrate whole life cost throughout design development. And the way we did that was through standardizing information exchange procedures, through a process model, and then developing the technology as a proof of concept that facilitates and streamlines this process. Essentially, it's a prototype application. So we use the IDF notation to start mapping information requirements and aligning those to whole life cost assessment. And we started from high level, from massing model and the layout. And as design progressed, this became more and more detailed. And so the information becomes more and more granular and considers different aspects. So here the prototype application consists of 6 modules. At the moment, the cost databases are kind of built manually from our sources, but we also envision to link those modules to an ecosystem of external applications, and we're working on that at the moment. So the first level of detail for a proof of concept was a massing model, and it also included the prototype and an inbuilt functional unit calculator for build-to-rent development. So the case study was a build-to-rent development, an actual building. So we developed interactive dashboards in Power BI, and those were aligned with the unit class classifications, but also with the RSCS coding for whole life cost. So we also used historical data from BLP Insurance, RSCS, and other sources. So the second level of detail was the functional unit model. And from that model, we extracted quantities of spaces and locations based on unit class classification system. So based on that, the dashboards become more granular. Yes. So they become more granular, and you can see the breakdown of CAPEX and OPEX and the other categories based on the unit class, but also the naming of the spaces in Revit. So the plugin was native in Revit, but we're looking to make it open source in the future. The third level of detail was the component model. And this means that its manageable asset was an object with properties attached as attributes to it. So we extracted this information from the model, and the dashboards become more granular, and they use unit class classifications for elements and functions, systems, products, but also the new rules of measurement, which is a UK standard for costing. And then you can see the impact of certain elements over 50 years based on historical data. Yeah, you can find more about 7D BIM in the press, and it has also been shortlisted for the Best Use of Technology Award. And yeah, thank you very much. That's me.
The next presentation will be made by Abdulaziz Fadul, a knowledge-based model for constructability assessment for building design using BIM. Mr. Fadul.
Thank you, Edmund. Hello, everyone. Thank you for having me. It's my great pleasure to present to you our research work at the University of Nottingham, which is about a knowledge-based model for constructability assessment of building design using building information modeling. It's really critical at the early design stage that we design for constructability by using our construction knowledge and experience to avoid any challenges or problems that may arise during construction stage. And that is exactly what is known by designing for constructability. However, it's not an easy to implement the concept. In fact, the practice now lack tool which may assist designers and construction managers to assess their design constructability and inform the decision-making process. Therefore, our research investigate how data modeling techniques and process can be used to provide a mechanism that can assist the design team to assess their design constructability at the early design stage, where they can inform the decision-making process and improve the design. In order to achieve the goal, we devised and met 5 objectives, starting by setting the challenges to quantify constructability, identify the requirements to measure constructability, developing and implementing a framework, and evaluating its effectiveness and validating its effectiveness. In order to measure constructability in its multi-dimension aspects, we identified the framework or the tool should be generic, scalable, flexible, comprehensive, simple to use, accurate in its results, and effective in delivering results that would enable the improvement of the design. The framework itself comprises of three main components: the design model, which we want to assess, the constructability model, where we represent our construction knowledge and experience and limitation, and the assessment model, which maps the knowledge onto the design features to inform the decision making. Here is the hierarchy of the constructability model. It has four main components: the AEC system, the rules of thumb, the complexity, the location, and each one of them meant to assess constructability from a different perspective, as I will highlight here. The AEC system meant to rank different construction systems and options based on their performance from a constructability point of view, by establishing constructability indices that based on the user input and based on any limitations. That is typically done through using the method analytical hierarchy process, AHP, where the user input or score the systems based on their input and based on their preferences to represent their capabilities and their limitations. So that's customized to them. At the end of the process, users will have ranks or are able to rank different construction systems based on the generated scores based on their input. So that is actually representing their construction capabilities based for different construction systems. The rule of thumb section meant to make use of rules compliance, so they can be checked in the design features, automating the process, and making sure we are imposing any limitations, any legislations, any constraints, instead of using classical method. The complexity meant to asserting the design features for facilitating the construction process using or qualifying different constructability attributes such as simplicity, automation, repetition by using same components in the design. Once we've customized the model, the constructability model based on the user input, the assessment model maps the constructability model or the represented model onto the design features extracted from the BIM model in order to inform the decision making. The framework is implemented as a plugin in Revit extension or in BIM extension using C# and .NET framework. So the user can interact with the model from automating the process of extracting the information and reasoning the knowledge as well. As a result, the user now can interact with the model from the user interface of Revit directly, where they can actually customize new or different constructability models, view their contents, and assess different design hosted by the platform Revit itself. They are also able to view the content of different constructability model customized by them, so they can modify the content or they can copy it to different or other uses, so that it can be used for assessing different design solutions. As a result, now users are able to assess different design alternatives from the perspective of constructability, so they can actually work on improving the systems or trying different construction systems or different alternatives, so to improve the performance. The reporting features within the platform enables the user actually to identify the area of improvement where they can actually work on it, giving the assessment results, so they can meet the design objectives in terms of time or cost or safety. To conclude, we in our research, we identified the requirements for measuring constructability, and we implemented a framework that actually enable users to measure or assess their design constructability based on their subjective views and requirements. The framework demonstrated the possibility of using BIM in order to assess design constructability based on BIM design solutions to enable the optimization and checking and examination of different design alternatives to meet the objective and objectify the subjectivity of constructability. That's all. Thank you very much for your attention. And if you have any questions, please contact us.
Thank you very much, Mr. Fadul. The next presentation will be done by Fado. The topic will be to develop integrated, incremental, and multi-scale methods to grasp comfort and quality of public spaces. Mr. Delval.
Hey everyone, can you hear me? It's okay? Yes. So I will first introduce myself as a German architect and a French state engineer. I'm currently working, sorry, I need to do the diaporama. I think it's okay. So I'm currently working at the ICCCBE, which is a French public administration for construction. And I will present our last work on comfort and quality of spaces through the BIM technologies. So I have 3 parts in my presentation. The first one is about the way we built the multi-scale BIM model to assess comfort. And then I will talk about the scientific methodology we develop in our work. And my last part will show how we approach this very complex question of the quality of use of public spaces. So let's go with the first part to understand is that we didn't work actually with the BIM itself. We worked with the PostGIS database that we directly extracted from the different BIM model on the area of interest. So we have had this, I would say, this big chance to work with an operating partner to complete our work, which is Paris La Défense. Maybe you know Paris La Défense as it is the first European business district. I have to say our partner was very involved in our research and provided us many use cases to implement our results. So to assess comfort, we had to perform many simulations like aerolytics, acoustics, solar reflection. And for each simulation, we had to structure this required data into parameters set using BIM standards. So we use CTJML for the city environments and IFC standard for the building model. So in order to perform the CFD simulation, we had to adapt the model, and we developed algorithm to do it automatically. Something we did before by hands, which was really, really time consuming. So it was good to automatic that things. Another important thing we had to develop is a converter from IFC to CTJML. The thing is that BIM program like Revit, ArchiCAD, Allplan are only exporting in IFC so far. So we had to develop another algorithm to convert from IFC to the CTJML format. So I will now talk about the scientific methodology we built to assess comfort. So I have to say that we made pretty hard collaborative work between our health and comfort department and my IT department, as we don't have the same way, I would say, to understand the different issue we had. So here you can see the simulation we ran to evaluate the overall comfort. We had to work with conduction transfer as well as convection and radiation on human being sites, with the human being things, which is not very common approach for an architect or a urban planner. One of our first results is that it was not really possible to give a global key indicator for comfort. Comfort is always relative to uses and times. So to make that understandable for you, I feel good because I am smoking a cigarette at 10 a.m. at this area. If I ride a bike, it's different, same condition, and I will not feel the same comfort. On my screen, you see the results right now. And for each simulation, for each pedestrian activities, you get a time history for simulation of from 1 to 5 for the worst to the best comfort level. So my last part now will be about an application of our work through tools we developed for urban planners to manage and monitor the quality of public spaces, which was actually one of the main challenges for our partner it was addressing to us. So with our free program, maybe you know FBIM, you can draw specific areas on the simulation maps so as to define the most interesting area to study comfort assessment according to the pedestrian activities. So on the bottom right, you can select time and area to get comfort results. You got 1.5, which is not a good comfort information. So our main purpose was to evaluate the quality of urban spaces. That was the goal of Paris La Défense. And we had to enlarge the research through a user-centered approach, and that we work with our scientists and scientists for human science to define. So this is our last work. We wanted to use our result to evaluate the quality of public spaces during workshop with citizens on urban planner. So we are now able to define areas with different purposes like relaxing, working, and we can add the simple furniture to compare with the first version. So this is another challenge for us, was to connect our work with the climate change on the area. And the first thing we did is to integrate the climate model in the BIM model database. That is what you are looking here. And then we integrate the new data of the climate for tomorrow and to know what will be in 20 years or 50 years. So let's go for my conclusion. So I will say digital let us perform a multidisciplinary approach where we made experts of IT, comfort, as well as human science work together. This is quite interesting. And we can still have many applications to IoT, machine learning, or link data. Our chance is that Per since 1 year is now operating the whole area. It's not only urban planner. So we will have many opportunities, other opportunities to work with. And finally, I will say there's still a lot of challenges on the work to evaluate comfort. So there's many data, many types of data, many actors, and we will definitively continue our work on that topic with our health and comfort department to bring more practice in our results. So thank you very much for your attention.
Made by Luisa Bochat, augmented BIM workflow for structural design through data visualization. Bochat.
Hi, everyone. Thank you, Edmond, for the introduction. I am Luisa Bochat. I'm a master's student at the University of São Paulo and a structural engineer. I will present this study which I developed with my tutor, Professor Fabiano Correa. I don't see the slides. I don't know if they, okay, I see them now. So this was a study that I did at the very beginning of my master, and this is the area that I'm researching now. You can please go ahead. So it's been decades since the impact of computation in structural engineering started to be discussed. The first documentation and analysis software prototypes date from the 50s and the 60s. In the 90s, a survey in the UK showed that already 68% of structural engineers agreed that IT was accelerating the functions of engineering. I think, yes. Okay. So this close relationship evolved with the increasing power of computation. Now it is possible that engineers explore and amplify in design space before reaching a final solution, mainly through parametric modeling combined with analysis. And this culminated in what is coined in literature as big design data, large amounts of data that have been generated during design rather than passively collected. In this context, we believe that data visualization can be a powerful tool to enhance design and collaboration in structural engineering. But the question then is, how is this data? Depending on geometry, load combinations, model assumptions. This structural database is reached from 1 gigabyte to 10 gigabytes per model version. The way this data is organized also varies a lot, given the use of different software within the same project in a workflow. So we have different geometry modeling software, then we go to analysis and post-processing, and this complicates the whole process. Communicating this data is essential for collaboration. So externally, we have the need to respond to constant changes rapidly, which requires a focus on information. And internally, we need to ensure the same quality in a team's design. So it is important to establish KPIs, key performance indicators. Also, visualizing the data is important for optimization. And it's not only to reduce weight, but also to be able to empower the designer to navigate through better aesthetics alternatives or innovation alternatives. The increasing adoption of BIM by structural engineers is an opportunity to create a better workflow in which visualization is integrated in design and collaboration. So through an extraction, transformation, and load of information from a BIM software to a data warehouse, we can see the application of data science such as visualization. In a traditional project workflow, the design process is divided into 5 phases. So input, concept, then schematic design, detailed design, and construction documents. Generally, several iterations happen between architects and engineers on the phases mainly between 2 and 4. During these phases, those aspects of structural data that I talked about have variable impacts and potential. Impact here is defined as a measure of the disturbance caused in the workflow, and potential measures the chances that this data generates relevant insight for the project. For example, we have, regarding size and variability, we have a large impact during the analysis and sizing of elements, and regarding optimization, we have a large high potential of using that during the concept phase, which decreases along the other phases. It is proposed then that an augmented BIM workflow could be used to explore the potential of visualizing this data in structural engineering by adding a parallel data and control step. This step depends on the establishment of key performance indicators from the beginning of design. In this implementation, we focus the data and control for internal collaboration. So basically, this would apply between phases 3 and 4. This is achieved by conducting an ETL process inside a BIM software, creating our data warehouse for later visualization. In this specific implementation, our information sources are Excel spreadsheets with structural model information and a Revit model with geometry information. The ETL is applied in Dynamo using also Python components when necessary. And the visualization is done with the creation of a dashboard in Power BI. This approach was applied in this case to a past project inspired by an existing one, but with modified geometry to keep its confidentiality. Some features that make data visualization especially useful and that are present in this case are the high structural requirements with long spans, long cantilevers, causing the use of a lot of different sections to keep the project within budget, inclined axis, which caused low element repetition, and of course the design by different engineers in parallel, which made smooth internal collaboration rather challenging. From this Revit model, we implemented the data extraction, transformation, and loading inside Dynamo. The overview of the script is shown in this diagram. This data was then exported to a table, which could be easily loaded with a query in Power BI. Then a dashboard containing 9 graphs was created for this specific project and context. The choices of the graphs and the final layout were derived from an analysis on the practicality of and ease of understanding the data. The software also allows to plot geometry and basically any programmable KPI. It is also possible to filter data and geometry at the same time, which is quite useful for collaboration. For instance, by selecting here the bracings of block B in the filter, one can instantly see their shape, quantities, capacity ratio, percentage of weight that they represent in the project. Well, this work shows that it is possible to implement the proposed data and control step and create an augmented BIM workflow for structural engineering. This was a study developed at the very beginning of my master's, and a wide range of applications of this approach are possible and will be the object of future research. Thank you.
People, process, technology in construction for balancing knowledge, distrust, and motivations. Mr. Meda.
Thank you, Edmund. Hello all. Good afternoon in Europe, good night in Asia and Australia, and good morning in Americas. I'm here to present the work that Edmund just said the title, and on behalf of the group of authors that are presented on the first slide. This was a common work developed by Portugal, the Faculty of Engineering in Porto, and the Brazilian Coast Engineering Council in Brazil. So we took the advantage of having this collaboration to develop this work that I'm going to state a little bit more on the motivation. So the outline for this presentation, we have motivation and the objectives that highlight what is behind this work and the reason by having these two institutions doing this together. The methodology that was adopted to do so, and then the development findings, discussion, and conclusions focused on the risks and failure that can represent less successful implementation. So the motivation to do this research comes from previous experiences, both in Brazil and in Portugal, on implementing a large innovation projects in the construction industry, and also the postgraduate classes that we are developing for Brazil. So we had to scout several people, and it was an opportunity to get more knowledge from that. So innovative actions are always difficult, and in the construction industry can be even higher. So the unsuccess of this implementation can have big costs on the mindsets. So we took the opportunity of having the integrated design and delivery solution research roadmap from CIB, and we balanced the dimensions of people, process, and technology. So based on the background experiences and scouts from Brazilian professionals, so people that are working in supervision and design, we can understand the knowledge regarding some technologies and the confidence and distrust of their use. So the methodology to do this research work took a basis on the literature review that we approached with the Price Waterhouse Industry 4.0 document and the IDDS imperatives, as well as previous experiences. And we select by having the classes and the postgraduate, we developed a survey that was part of one of the classes, and we did it in 2018 and in 2019, and we achieved some outcomes and guideline strategies for implementing innovations in the construction industry. So the survey questions are based in two questions. One, very simple, to fulfill this matrix according with the technologies from Price Waterhouse and the maturity at technology, people, and processes level. And then a second, that was a development question. These are the results that we got in 2018 from 52 respondents, that where we can see that technology is always the more mature issue, more mature dimension in most of the technologies, followed by processes and people. And actually, in 2019, we repeat the survey with the same type of profile, of stakeholders profile, 45 respondents, and we got quite similar results on that, and we are going to talk a little bit more about it. So there is a complete alignment between the results of both surveys. What is are using the same profile. It's very interesting to have that, and then other results that we had are the following. There is always a higher maturity rate in 2019 when compared with the 2018, meaning that strategic reports and actions are taking effect as the awareness improves from one year to the other. Likewise, these stakeholders are more aware and more ready to accept or to go through a process of implementation of technologies as cloud computing, information digitalization, and connectivity, because these are the technologies that they deal on a daily life. So they are the ones that they are more close related. So the readiness level to implement the scouted technologies can vary significantly depending on the feelings and potential benefits of the technologies for their work. But this can also lead to some mindsets and some disturbances on the adoption. So the survey results provide some interesting insights in terms of the strategies that can be adopted with this type of stakeholders to implement new technologies in their processes. As I mentioned, more effort needs to be done at personal and process level once the technology level is a little bit more mature or a little bit more aware. So the conclusions is that when we go for a new implementation process of innovation and technologies implementation process in the construction industry, we need to have more awareness and more confidence about the fears and the enablers of the stakeholders. With this knowledge, we can go through a streamlined implementation process, and using this type of approach, people, processes, and technology, we can understand what must be pushed at each type of stakeholder. So, thank you very much.
Very much, Mr. Meda, for your presentation. We'll have the last, obviously not the least, presentation of this session will be made by Raisa Freitas, Project Management After BIM Introduction, Paradigm Shift or Reiteration. Very interesting.
Hello.
Please, Raisa.
Thank you. Hello, everybody. My name is Raisa. Today I'm going to present a paper about project management after the BIM introduction that I've written with Professor Adele Francis, Edmond Moresco, and Silvio Melhado. In this paper, we start by talking about the difference between BIM and CAD, and this raised the question, would the transition from CAD to BIM be similar to what happened from paper drawings to CAD? Because CAD also had a lot of potential that was never developed or explored because they weren't feasible. Even though BIM implementation is increasingly growing worldwide, there are many difficulties that companies and professionals face when they try to integrate BIM in their work routines, such as interoperability, contractual inadequacies, and incorrect usage of BIM tools. In the literature review, there is some history about how CAD advent gradually changed the design process and professional roles, and when BIM started to be adopted. Next slide, please. Thanks. Also, in the literature review, we talk about how productivity improvements can be achieved by optimizing existing processes with BIM, and that companies should explore new contracting models. Some of the elements that impact BIM adoption are the leadership, strategic planning, training, resources, processes, and knowledge management. And it relates to this paper's objective to discuss that impact BIM, that the impact that BIM caused on the work routine of construction professionals. This research was based on a literature review and a survey to understand better how professionals are seeing BIM. And the survey method was used to collect data from a specific sample of a defined population using a questionnaire. And the survey was answered by 85 professionals, mainly from Brazil and some from Canada, Europe, and Asia. They are experienced engineers and architects with bachelor and master's degree, with ages varying from 26 to 55 years old mostly. And there is a concentration of respondents working in the commercial, residential, infrastructure, and industrial sectors, and they are most young professionals, mainly from 6 to 10 years of experience, and we had almost the same number of answers from women to men and men. And they are mostly beginners users of BIM, using it only for 2 years, even though this method came up more than 2 decades ago. And this seems to suggest that professionals are still adopting BIM in their routine, so there is a long way to go until they reach the adequate maturity level. Most of these professionals believe that BIM represents an improvement in their processes since they accomplished their aimed benefits. They also believe that BIM has a considerable impact over most project contracts, which agrees with the statement made by the World Economic Forum that says that BIM proposes a new way of collaborating and sharing information between stakeholders. In this professional's experience with BIM, there was an improvement on team collaboration and project management. But regarding communication, the expectation of the majority wasn't met. These kind of failures to reach better results with BIM can have many reasons related to the adoption process, according to the literature review that we did. These professionals also believe that BIM not only improves internal team collaboration, but also enhances collaboration throughout the building life cycle and among all construction projects, stakeholders, and disciplines, according to the answers. In addition, increase in productivity is one of the main goals of the field, which is an evaluation of the data from the graphics suggests that it is achievable with the use of BIM. And it is also believed by the respondents that the communication between generations has also been improved with the advent of BIM. And the work routine for 70% of these professionals had a significant impact with the advent of BIM. New guidelines, standards, and regulations that emerge with it also have been impacting the professional's daily routine, and pre-existing roles are suffering modifications as well. For instance, project managers are becoming BIM managers. Most professionals also believe that it is crucial to organize the method of working with BIM through the development of a BIM implementation plan, BIM execution plan, and finally do pilot projects. It's really important. Concluding, clearly, the civil engineering transition to the digital era is still in progress, and it's going to take some years to deploy. Several issues hinders the BIM deployment, such as legal obstacles because of the obsolescence of contractual models and the evident need to redefine roles and responsibilities. Moreover, matters related to poor education background related to BIM that is offered in universities all over the world. Besides that, the construction sector worldwide is not used to work with collaboration between stakeholders, and neither they have an exemplary communication between them, which is fundamental when working in BIM. It all added to the fact that management practices in the construction sector are not employed as much as it should, are some of the factors that originate a low satisfaction of construction professionals with BIM adoption results. And the usage of this new method is still in the beginning, and the innovation must get to a maturity level where it is easy to use BIM as it is easy to use CAD nowadays. So this is our article. Thank you very much.
Thank you very much, Raisa, for this presentation. This concludes our session. We'll have the discussion panel. I see a question from Miriam Ador, who asked paper number 6 for Maria Lazani. How do you think about accuracy of data behind the scenes, from the design phase to the facility phase?
Yes. So one of the main challenges was the availability, the accuracy, and the granularity of the databases. So for this purpose, we use historical databases to begin with. So BLP's insurance has collected data over 25 years. And the RHCS have developed very reliable benchmarks. But of course, the vision is to start actually collecting information, improving the benchmarks, and of course, linkages to the model and using appropriate code is another issue that we have encountered. So those are the major issues that we need to overcome.
Okay. The next question has come from Kayami Cavalcante for the paper number 10, the Pedro Meda. Obviously, he thanks you for the presentation, and he would like to know more about the respondents to your survey. Were the construction company, design firms, construction system fabricators, so on? Where I think it's missing a small.
Yeah, thank you. The survey was developed on a postgraduate program that we delivered to Brazil, 2 editions, one in 2018 and another in 2019. And it was mainly to professionals, meaning that these professionals are engineers and architects working in design teams and some leading construction works as work director or supervision. So I would say that, yes, design firms, construction companies, construction system fabricators, I would say that less people or none were involved, because the postgraduate was on construction management and design management. So they were mainly people working during the design phase and during the construction phase.
Okay. The last question comes exactly from Mr. Meda to the paper 11 to Raisa. Did you explore some social aspects of enabling and obstacles regarding BIM adoption on your survey?
Some there's an obstacle regarding. No, we didn't actually. This survey was mostly to understand how professionals and academicians of the construction sector is facing BIM and what are the outcomes that they are getting from it, but it didn't have social aspects in the answer in the questions that we did. Sadly, but it is a really good survey to think to follow this kind of research.
It's okay. Now I see no more questions on the panel. So, yeah, and I like to take 1 minute to thank everybody. For people who doesn't know me, I'm with the organization, and please don't feel bad that I for at least 35 years, and in fact it started in 1982. This was the first conference, and I attended the second conference in Hangzhou in China, and since then I follow most of the conferences all over the world. At this point, I'm the treasurer of the organization, and I encourage you to continue and perhaps to have a nice continuation. Thank you very much again for this presentation, and this concludes our session number 2A. Bye-bye.